All right, first, coffee. Second, like and subscribe my videos. Third, this is a foundational video for what we are doing moving forward. It is an absolute must-watch video. Like every single part of this is crucial to what we're doing basically the rest of the year. Okay, so it is a must-watch. Please tune in for every second because it is very, very important. Okay, so anyways, now that we got that out of the way, let's go ahead and begin. So, degrees and radians. We are going to learn about what a radian is today. All right, but first we're going to kind of talk about how a couple angles work. This is kind of a new way of describing angles, okay? And then we're going to go into what a radian is. Now, you've probably seen that on your calculators, right? You've always kind of heard about, oh, get out of radians mode, right? So, just to show you, right, if you were to click into mode, right, what we've been working on so far is we've been working with degrees, right? In degrees, if you do a full rotation, you go 360, okay? We're going to learn what a radian is in a sec, but I just want you to know for now that a radian is just a different way of measuring angles, okay? That's it. It's just like, you know, centimeters is a different way of measuring than inches, right? Same with degrees and radians. They are a different unit of angle measurement, okay? So again, you know, like feet is a different unit, miles, different unit. Same with degrees and radians, okay? They're just different units of angle measurement, okay? So before we get overwhelmed by it, that's what a radian is, okay? Cool. So let's go ahead and talk about angles in general, okay, and what initial and terminal sides are referring to. So the initial side of an angle, okay, is going to be kind of where it starts. Okay, that is where the angle starts. All right. Really, all you need is a picture for that. Right. I just like to label that part right there, and then terminal right here. Now, a lot of the angles we're going to be working with moving forward are going to start at like this spot right here. Okay. It's always going to have, you know, like you've got, say that's the origin. This is like your positive x-axis. Okay, and then it's going to open up from here. So it's like the angle starting here and then opening up to there. So that would be the angle measure. Okay, cool. Initial and terminal sides. And by the way, there's a lot of vocab in this video. So the vocab, super important that you see words like this, initial, terminal sides, boom, got it. Angle and standard position, that's our next vocab word. Okay, so a lot of this will have to be known, right? Like you have to know this vocab. Like you need to be very comfortable with using it. All right, angle in standard position. So angles in standard position are going to start, really the only requirement is that they start at the positive x-axis. Okay, they start at the positive x-axis, similar to kind of what we had here. Okay, so an angle in standard position, very simple, just double checking I'm not missing anything. Yeah, so an angle in standard position will be something like this, right? Where you kind of have this right here, just to show you, right? I like to draw like an arrow, okay, to kind of show where the angle began, right? This is where the measurement begins, and then I'm opening up into the angle. So this angle right here would be in standard position, okay? And again, the only requirement here is that I'm starting my angle measurement, start at the positive x-axis. So I've got, you know, this, that is the measurement, right? If I've got an angle there, that is my angle. That is an example of an angle in standard position. Cool. Okay, a positive angle. Here's an example of a positive angle, right? Where let's do like a concrete example. Let's say like this is like 80 degrees. Okay, it's opening up here. Looks like it's pretty close to about 80 degrees. Okay, so again, we're starting here, opening up and beginning our measurement. So this is, we'll go ahead and say this is counterclockwise from the positive, whoa, left out a whole bunch there, positive x-axis. Okay, so I'm starting from, you know, counterclockwise from the positive x-axis. So I'm starting here, and I'm going counterclockwise, counting. Okay, negative angle. Well, if this one's counterclockwise, what do you think this one will be? Right. So a negative angle is going to be clockwise. I know that's a little bit backwards, but that's just how we do it. Okay, that's just how whoever decided positive angles and negative angles are going to be, and it has its benefits, as you'll see later. Okay, so negative angle, this is going to be clockwise from the positive x-axis. Okay, so if I'm going to have a negative angle, I'm starting my measurement from that positive x-axis. So an example, right, would be something like this. If I was starting here and I'm opening this way, okay, maybe let's say that that's, I don't know, negative 80 degrees. Okay, so that would be an example of a negative angle. Okay, so again, it depends on where I'm starting. Okay, I'm always going to start at that positive x-axis. If I'm opening up counterclockwise, okay, that's 80 degrees. But if I open down, that is going to be negative 80 degrees. Okay, so let's go ahead and do some examples to kind of shine some light on this. Sketch each angle in standard position. Okay, 46. We're just sketching, right? This does not have to be perfect. I'm not looking for perfection here. But 46 degrees. Okay, if I were to open up here, right, that's going to be very close to my 45. So somewhere in there. Okay, 46 degrees. Again, I like to draw the arrow. Okay, I'm starting here, going there. That's 46 degrees. Okay, the arrow is important, kind of shows you where you're starting. 254. Okay, this is going to be a little bit of a funky one. Okay, because we're not used to seeing angles that are, I don't know, greater than 180. Okay, that's where this comes into play. That's where this standard position whole thing is crucial. Okay, so 254. From here to here, right, starting here, that's 90. 280, sorry, 0, 90, 180, okay, and then 270. Okay, so when I go all the way around here for an angle, that's 270. So that 254, I'm just going to backtrack from that 270 about 16 degrees, so somewhere in here. Okay, not perfect, somewhere in that vicinity. Okay, so here we go. Yeah, somewhere in there. Just every once in a while I get a little nervous. Okay, all the way around, that is my angle. Okay, if you were to label it, I don't know, maybe sometimes you'll see it as theta. It's a little bit weird, okay, but that is the angle, all the way from this to here, okay, to there. 600 degrees, all right? So with 600 degrees, let's think about what's happening. Starting at 0, 90, 180, 270, 360. I'm still not there, okay? So really, the truth is, we don't know what that is yet, because we've actually got to do 600 minus 360 to kind of get the position. That's just to get the position. Okay, so we've got 240 is where that one will be. Okay, so again, this time we're going around 0, 90, 180. Okay, and then 180 plus 60 will get me that 240. So somewhere in there. Now, here's the trick on this one. Since it's 600 degrees, 600 degrees and 240 have the same position, but I have to go all the way around once. So I'm going to start here, go all the way around, and then end right there. Okay, so I know that's a little bit weird, but that's how some of these angles are going to work when they're greater than 360. Okay, again, 240 is going to be in that same position. It's just you have to go all the way around once with the 600 in order to complete it. Okay, so that is my angle. That is a picture of my angle for 600 degrees. Okay, so the arrows are actually extremely important, as you're seeing here. Okay, in order to measure and show, really show what the angle is referring to. All right, negative 120. Okay, so this is negative, so now I'm going to be starting here and going clockwise. Okay, so I'm here, 0, this is negative 90, right? If I'm starting here, negative 90, okay? And then I'm just going to add, or subtract 30 more, so it's going to be right there, okay? And now notice, this is kind of a similar spot, right? It's close. Actually, it's in the exact same spot. Okay, let me go ahead and say that. It's in the exact same spot, but the difference is the arrows. Okay, the difference is the arrows, right? So if I start here and go all the way around once and then come back, that's 600 degrees. But if I start here and go backwards, that's going to be negative 200. Okay, so that's my angle there, right? We can label it as theta if you really wanted. Okay, right? So sometimes you'll see that theta. Okay, that is positive and negative angles using our angles in standard position. Okay, just remember that standard position starting at the positive x-axis. Okay, if it's a positive angle, it's going to start the direction that it's going to start counting is counterclockwise, and then for negative angle, the direction it'll start counting is clockwise. Okay, cool. Got that out of the way. All right, radians. Here we go. Okay, radian measure. Let's talk about what a radian is. All right, so I'm going to start off with saying what 1 radian is. Okay, I'm going to go ahead and write it first. A radian, okay, is the angle. Okay, one radian is the angle formed when the radius is wrapped around the circle. Okay, just one length, 1 radius. Okay, I'll go ahead and say when a radius. Okay, a radius. Okay, now let's see what this looks like, right? Maybe you're not a visual learner, or sorry, maybe you're not a, I don't know, what is that, word learner? Okay, I'm more of a visual learner, me personally. I think for a lot of things in this class, it's very crucial to see a picture of what's going on. Okay, so first of all, let's start off with this. Let's look at this circle. So I have a circle. Okay, the radius of this circle is from here to here. Right? The radius always connects that center, right? The center of the circle to an edge. Doesn't matter what edge, right? But the radius length, typically we kind of show it right here, right? From the 0, 0 to that right side. Okay? That's one length of the radius. I'm going to go ahead and highlight this. Okay? So we got the radius in blue, that length in blue. Okay? The a radian, right? Notice that those two words are similar. That's not a coincidence. Okay? A radian is the angle formed when that radius, that length, is wrapped around the circle. So we're actually going to take that length, and it's like we're picking it up, and we're going to start it right there. So this length, okay, it's not going to be perfect, but this length, somewhere in there, okay, this is my length of the radius. So I'm going to show it. I'm going to go ahead and highlight that in blue as well. Okay. Going to go ahead and highlight that in blue as well. Okay, so that is my radius length. Okay, so this angle here, that angle from here to here, is 1 radian. Okay, in your head, you can picture 1 degree, right? Very, very tiny, right? Right next to that positive x-axis, right? An angle of 1 degree, that's very small. 1 radian is a lot bigger. Okay, just estimate here. Okay, I believe 1 radian is about 56 degrees. Let me just double check that. Okay, I actually don't personally think about radians that way. Yeah, so it says it here, it's about 57 degrees. Okay, and we'll talk about why that's the case. Well, actually, we probably won't, but something to keep in mind. Okay, it's about 57 degrees. Okay, it doesn't come into play a whole lot, but it's an interesting fact. Okay, so 1 radian, that's what it is. All right, it is that angle right there. All right, it's just a way of measuring compared to the radius. Right, the units here are kind of using what my radius is, okay, in order to get an angle, right, in order to get a measurement of an angle. Okay, now let's do something. Let's do an interesting activity here, and we're going to use my favorite, or definitely one of my favorites. We're going to use some Twizzlers. Okay, so this is going to be fun. We're going to go ahead and do this activity right here. We're going to pause on the radians. okay? Because there's one thing that's important about radians that we need to understand in order to get the measurement, right? So what we're going to do, just giving you a heads up, okay, is if we go all the way around in a circle, we've traveled from 0 to 360 degrees, okay? We need to find what that corresponds to with radians, okay? Because that's actually going to be kind of the conversion point, okay? If we can understand that, in general, it goes from 0 to 360, well, what's the whole for a radian? If we can do that, then we can start converting everything, and it'll be kind of full circle, no pun intended, kind of wrapping everything up, and then we can convert from degrees to radians, and then we can understand radians a lot better if we can just find what one whole rotation is for a radian. And that's what we're going to find right here with this awesome worksheet. How many radians are in a circle? Okay, so if you're going to cut the Twizzler, all right, the length of the radius, ooh, that is probably really loud on the video, I'm sorry. We will call the radius length of the radius 1, okay? Here we go. I'm going to get my Twizzler, and I'm going to do that right there, and I'm going to cut it off at that spot. Not going to be perfect, okay? So that is 1 radian. If I wrap it around here, right, that is similar to what we just did on our paper, right? It doesn't wrap perfectly, right? But that angle, the end of that, right? So from here to here, like this, we'll draw it. We'll go ahead and draw it. That angle right there is 1 radian. Okay? We're going to see how many times, right, I can go all the way around. Okay? So I'm going to go ahead and just make a bunch of them like this. And we're going to see how many fit. It's not going to be perfect. Okay? It is not going to be perfect. So let's just keep going. Make a bunch. But it's kind of fun. It's kind of fun to see what it ends up being. Uh-oh, that one's a little big. Keep that for later. Okay. And for the sake, I'm not going to spoil it. Okay. I'll eat that bit. All right. Now we'll make one more, just in case. I hope you've enjoyed me. I could be on like a chef show here with these Twizzlers. Okay, we've got all our Twizzlers. Put those away. All right. We're going to explore how many we have in this circle. Okay, so here we go. Here's all my pieces. Okay, I'm going around here. It's hard to get the little bend. That's okay. We're not going to worry about the bend. Okay, there's that one. There's that one. Okay, and there's that one. So you notice, just for the to go all the way around the circle, it's a little bit more than 3. Okay, let's keep going. Halfway around the circle, right? Halfway around the circle will be a little bit more than 3. Okay, there it is. All right. Let's see. Okay. We're going to link these up a little bit like that. A little better. There we go. Okay. And then over here, it doesn't quite use a whole lot. Okay. It uses, I don't know, about half. About half. Like not quite there, but approximate. So let's go ahead and rip that one off, right? So it's 1, full 1, 2, 3, 4, 5, 6. And then, I don't know, somewhere in here. So we'll say that is about, I don't know, a third of what we had, okay? Somewhere in there, okay? So maybe someone does more, I don't know, 6.5, 6.3, somewhere in there, okay? So about 6.3 times. And the question is, does that seem familiar? All right? Maybe it does, maybe it doesn't. I don't know. okay, depending on how comfortable you are with your numbers in general, all right? But let's explore something here. Maybe we didn't see the pattern here, okay? Maybe we did see the pattern here, though. What is everyone's favorite number that is related to 3? Okay, everyone's favorite number related to 3. Think about it, but it is going to end up being pi. All right. So this 1 full radian, okay, what it's saying, right? This is 1 radian, 2 radians, 3 radians, 1 pi radians, right? Pi radians. In other words, 3.14 radians. Go halfway around. Okay. 6.28 radians go all the way around. So we were pretty close, right? 3.14 times 2, 6.28. So 2 pi radians all the way around. That's like my 360. Okay? So everything in radians is going to be related to pi because it happens to be the case that if we go all the way around, it's 2 pi. Okay? Now that should make sense with your geometric formula of circumference in a circle, right? Anytime you have a radius, the circumference, right, is 2 pi r, right? 2 pi r is a circumference formula. In other words, diameter times pi, okay? But 2 pi r, that formula is why this all works. Okay, so there's 2 pi all the way around. 2 pi radians, okay, all the way around. Cool. So that is the 360 equivalent. Okay, so let's just write that on this paper. So if I go all the way around, okay, if I was working with degrees, that would be 360. But if I was working with radians, that would be 2 pi. So again, we're going to relate everything to that, but we're going to keep it in fractions and we're going to keep it in terms of pi. And I'll show you what I mean by that in a sec. Okay, so we now have seen the Twizzlers go 2 pi around the circle. And I'm going to go ahead and pause it just because I want to give you a break. So take a brain break. That's a lot. Okay, take a brain break, and I'll start the second half of the video after this.